A runway incursion does not always begin with drama. Sometimes it begins with a message that sounds almost right. Imagine a fictional airport at night. One aircraft is preparing to depart. A service vehicle is crossing near the protected runway area. On the radio, a response comes back quickly, confidently, and just slightly wrong. Nothing here is a real airport. No real clearance is being taught. The point is simpler. Runway safety is a system of barriers, and communication is only one layer of that system. In this episode, we are going to slow the chain down. We will look at the protected runway area, the readback and hearback loop, airport layout, visibility, workload, and the way a safety investigation should ask system questions instead of hunting for one villain. The dangerous part is not that one person makes a mistake. The dangerous part is when several small weaknesses line up at the same time. First, we need the definition, because the word incursion can sound more dramatic than the basic idea. The FAA describes a runway incursion as any occurrence at an aerodrome involving the incorrect presence of an aircraft, vehicle, or person on the protected area of a surface designated for aircraft landing and takeoff. That wording matters. It is not only about two airplanes nearly colliding. It can involve a vehicle, it can involve a person, and it is tied to a protected area around a surface used for landing and takeoff. Different authorities may organize categories and reporting details in their own way. So this episode labels the definition as FAA source material. We are not turning it into legal advice or a global rulebook. For viewers, the key idea is this. The runway is not just a strip of pavement, it is a protected operating space, and entering that space incorrectly can break the safety picture very quickly. Runway safety is not protected by a single magic rule. It is protected by a stack of barriers. There is the instruction or clearance layer. There is the readback and hearback layer. There are airport signs, markings, lighting, diagrams, and sometimes surface surveillance or runway status systems. There is also plain situational awareness, people understanding where they are, what runway is active, what is moving, and what is expected next. The important thing is that these barriers overlap. If one layer is weak, another layer may still catch the problem. But if the layout is confusing, the radio is busy, the visibility is poor, and everyone expects the usual movement, the system becomes less forgiving. That is why a good safety explanation does not ask only, who made the mistake? It asks which barriers were supposed to catch this, and why did the chain continue? The pilot/controller glossary gives a simple meaning for read back, repeat the message back to the speaker. In aviation, that loop is valuable because it turns a spoken instruction into a chance for detection. One party sends the message, the other party repeats the critical idea. The first party listens again for whether the repeated message matches the intent. That last part is easy to underestimate. A readback is not only the act of speaking, it is also the act of hearing the readback and catching a mismatch. This episode will not teach real phraseology, and the screen will not show operational examples that someone could copy. Instead, we use a simplified loop, message, readback, hearback, correction if needed. When the loop works, an error can be caught while it is still only a sentence. When the loop fails, the error can move from the radio into the airport surface. Now, put the communication loop onto a physical airport. A runway is long and obvious from the air, but the surface around it can be mentally complex. Taxiways cross, holding points repeat. Similar signs appear in different places. A vehicle route may pass near a protected area. At some airports, hotspot markings and local safety materials exist because certain locations have a history or geometry that deserves extra attention. For this video, the map is completely fictional. It is not a chart, not a taxi route, and not an instruction. It is a teaching board. The lesson is that layout can turn a small misunderstanding into a spatial problem. If someone thinks they are at one point but they are actually at another, a correct sounding response may still fit the wrong mental map. Runway safety depends on both words and geometry. A risk chain becomes stronger when the environment adds pressure. Visibility can be reduced. The frequency can be busy. A controller, pilot, or driver may be handling several tasks at once. The airport may be using a common flow that everyone has seen many times before. That creates expectation bias. The mind fills in what usually happens, even when today's instruction or today's surface picture is different. None of these factors automatically causes an incident. They simply reduce the margin for catching small errors. That is why the fictional board shows workload, visibility, layout complexity, and expectation bias as pressure gauges. They are not excuses. They are conditions that safety systems need to anticipate. A strong safety culture does not pretend humans will never mishear, misread, or assume. It designs barriers because humans sometimes do exactly that. Let's turn the fictional setup into a chain. First, the airport surface is already busy. Second, a message is heard almost correctly. Third, the readback sounds confident, but the mismatch is not detected. Fourth, the vehicle or aircraft begins to move based on the wrong mental picture. Fifth, another person or system notices the conflict late enough that the event becomes serious. This is not a real accident timeline. It is a simplified model for how defenses can align or fail. The useful question is not which single moment was the whole cause. The useful question is at how many points could the system have stopped the chain? That question changes the tone of the story. It turns the runway from a stage for blame into a map of barriers, signals, attention, design, and feedback. When this channel covers a real runway event later, the source standard has to be higher than a headline or a viral clip. A proper case file should start from official reports or official data. It should separate confirmed facts from assumptions. It should explain the sequence, the context, the safety barriers, and the recommendations. And it should avoid assigning blame from incomplete information. That is especially important in runway safety stories, because the public may see only one camera angle or one radio clip. Aviation safety investigations usually ask deeper questions. What did each participant know? What was visible? What was expected? What procedures or tools were available? And what organizational defenses existed? For this phone episode, we are not naming a real event. We are building the viewer's mental model first, so future case files can be understood more responsibly. Safety management changes the question. A blame-first story asks, who failed? A system story asks, which hazard was present, which defenses were planned, which defense weakened, and what feedback should improve the system next time. That does not remove responsibility. It makes responsibility more useful. If a readback error matters, then training, phraseology discipline, workload management, layout design, lighting, markings, surveillance, reporting, and local safety actions may all be part of the answer. Not every airport has every tool, and this video is not prescribing a solution, but the system view helps us look beyond the last person in the chain. Runway incursions are powerful teaching cases because they show aviation safety as a living network. Human communication, physical design, technology, procedure, and feedback all connected around one protected surface. Here's the takeaway. First, a runway incursion is about incorrect presence in a protected runway area. In this episode, that definition is FAA-labeled and used for education, not legal guidance. Second, readback is more than repeating words. The safety value comes from the loop, message, repeat, listen, and correct when something does not match. Third, runway safety is a barrier system. Communication, layout, markings, visibility, workload, expectation, surveillance, and safety reporting all shape whether a small error stays small. So the next time you hear a calm voice on an airport radio, remember that the voice is only the visible layer. Behind it is a network designed to keep aircraft, vehicles, and people out of the wrong place at the wrong time. Next, we will keep building that map. How tower approach and center divide the sky and why the voice changes as a flight moves through the system.